So welcome to this final lecture in the Francqui Chair lecture series on gestural interaction. And as we can see here on the title slide today, it will all be about evaluating gesture interaction. So Jean, the floor is yours.
Thank you very much for your introduction and welcome aboard to everyone. Good morning or good afternoon or good evening, depending on where you are. Indeed, I'll try to address the question, how can we evaluate user interfaces involving gestures? So far we have seen several aspects like for designing, for eliciting, for capturing, for recognition. But the last step, how to evaluate a user interface involving gesture, is still a very open question, since the body of knowledge for that is very limited today, as you will discover with me. First, I'd like to start with a few things about how I understand user interface evaluation, but maybe you can have, of course, another view on that. In general, in general terms, user interface evaluation consists of course, having a system on the left hand and comparing it to a reference model, which could be, of course, written in different ways, and to compare it in order to say how and where it is good enough or not good enough. But it's all evaluating is always with respect to something. It could be a reference, it could be a style guide, it could be a manual, it could be something, or it could be a user model. It's always with respect to something. So this is in general. And then, of course, we need to collect data. We have seen so far that we can have some metrics, measures, observations, and these data, of course, help us to feed the reference model, even if it is an imaginary model that we have in mind. Of course, we can have also ergonomic data when we really observe the users. So that's in general. Of course, we could also have more high-level criteria, factors, or dimensions, which are related to what do we want to evaluate in the system. Is it a certain goal, or is it useful enough, or is it usable enough? And of course, we can have several of them. Today, there are several sources about those high-level factors. Usually, I like to refer to one of my favorite standards, which is the ISO 25000, which is the ISO standard about software quality. Maybe I can also try to have, let me have a look if I can find it also on the web. For this purpose, the ISO standard is very general because it addresses, in principle, of course, any software, whether it is interactive or not. So this is probably the most encompassing standard about quality of software. And as you can see, it is decomposed into 8 high-level criteria, or called factors. Functional suitability, performance efficiency, compatibility, and of course usability. This is the one we are the most interested in for the moment. But also maintainability and portability from the point of view of the developer, not necessarily the end user. And today we are also very much particularly interested by user interface aesthetics, which is very challenging to measure. So if we go deeper into the usability criteria, there are, of course, other standards like the ISO 9241, which is about usability itself. The problem is that those standards are very general, so in principle they should be applicable to user interfaces involving gestures, but actually they are not specific enough or not concrete enough to evaluate such user interfaces. So if I'm considering just usability, we, according to the definition of the ISO standard. So this one, and this one is one of the most quoted standards for assessing usability. So usability is decomposed into 3 aspects: effectiveness, efficiency, and subjective satisfaction. So if I'm trying to do let's say a multi-factor model, we have, of course, effectiveness, which is the first dimension. So the effectiveness refers to the fact that whether an end user is able, yes or no, to actually perform and complete a task with the system. So effectiveness can be interpreted from the user point of view, whether the end user is able or not to complete a task, but it could be also interpreted in terms of the system, where we can have a recognition rate, whether the system is able to recognize a gesture with a good rate. Usually it should be above 90%, but also in a short amount of time. Because if I'm producing a gesture and I have the result after maybe 2 or 3 seconds, then the user will be either confused or discouraged. So from a system point of view, effectiveness can be measured by traditional metrics like recognition rate or recognition time, and they are usually conveyed through confusion matrices. So like here on the left, we have 5 gestures recognized by this system, and on the diagonal, it is supposed to say that the better the gesture is recognized, the better the recognition rate, and then the value here, it should be close to 1, which means if it is an ideal position, it would be 100%. So in this case, for instance, the caret gesture is pretty much well recognized, but the circle, surprisingly, although it is a simple figure, is not well recognized in this configuration, of course. And it is confused with the square. Why this confusion with the square? Because if I'm drawing a circle in space, in 3D, I'm not very precise enough, and sometimes the system may be confused by interpreting my gesture as a square instead of a circle. So we can come up with those confusion matrices, but this is from the system point of view. Another visualization, although I'm not an information visualization person, instead of a confusion matrix, it's also a confusion wheel, where the different classes are depicted on the radial point of view, and you can see to what extent some gestures are confused by another one. So for instance, if I'm going this way, I can see, well, I can visually interpret that the confusion between those 2 gestures is rather important. So a confusion wheel is a little bit difficult to interpret. Maybe you can say what you think, but at some point, especially when there are many classes, here I only have 5 classes of gesture, so it's okay. But if I have, let's say, 20 or 30 classes of gesture, the matrix becomes difficult to read. The confusion wheel is still affordable. Anyway, so all of these things contribute to effectiveness, but from the system point of view. The second dimension from usability is the one about efficiency. So if I say that the user should be able to carry out the task, and usually this is measured with task completion rate or task completion error rate, then the end user should be also able to carry out the task with efficiency, which means it should be fast enough to do that. Also, from the user point of view, efficiency is impacted by different criteria, as we have seen, like the learnability. If the end user has to learn some gesture, how would be the recall rate afterwards? Or how much time would I need to memorize a gesture and to keep it in my in my habits, and also, of course, the workloads. So all of these things contribute to the efficiency. So if we look at those inputs for efficiency, so there are different ways to measure efficiency. One of them is, of course, again, the NASA TLX, which is a very general purpose questionnaire for estimating the workload of any system, whether it is based on gestures, yes or no. But the nice thing is that it is decomposed into 6 sub-dimensions. The mental workload, which is more or less important for here, but physical one, which is very important for a gesture, also the physical effort, and maybe the frustration. So NASA TLX is, of course, decomposed into a series of questions that are asked to the end user after carrying out a task. But one version, the classical version of this questionnaire is that those statements or questions do not have any weight. What is important, I think, is that if we use the NASA TLX, this is something that we have done recently here, is that we ask the end user to what extent do you think it is important to have this dimension covered. Like for instance, in this case here, for one particular participant, this participant said that the effort is important, but the frustration level is not that important. The performance is important, but surprisingly, he didn't say anything about the physical demand, probably because of confusion with the effort. So if you want to try a NASA TLX, I really recommend this tool. It's a software, it's an application that is very, very useful and handy in order to conduct evaluation with NASA TLX. And the system computes everything for you. And also, most importantly, it asks to the end user, the participant, to what extent you believe that those 6 dimensions are important, yes or no. And this could be very different from one user. Maybe an end user who is not used with gesture will probably require more importance or will devote more importance to mental demand and maybe less to temporal demand. But an expert user who is frequently producing gesture will probably state that performance and maybe also effort are more important than the other ones. So I like very much this version because we can weight those different scales. So there are very different ways to measure efficiency. Another one which is so on the one hand, NASA TLX is very sophisticated, so it's demanding for the end user, the participant. But on the other extreme here, there is also the gesture scale, which states that for one participant, for instance, we ask one participant, 1, 2, 3, 4, 5, etc., to produce a gesture for a command. And we just look to what extent the gesture has been not only properly recognized, but also properly produced with the intended action. So in the end, this table provides 3 results. The perfect one is green check, so it means that user 1 produced the 5 gestures correctly, they've been recognized correctly, and they were produced as intended by the end user. So when there are 2 crosses like this, it is a double error. It means that the user not only did not produce the right gesture, or not as intended, and it has not been recognized. This one, for instance, was correct as an intention. Probably, for instance, the participant said, okay, I want to draw a circle. So he did actually produce a circle, but the circle was not recognized. So this is not the same as this one, where probably the intended gesture was not correct, and it was not correctly recognized. So this is a very simple way to represent that, and straightforward in order to estimate the efficiency. Other people are also using of course, percentage of errors, which is also a sub-criteria of efficiency. Is that to what extent people may produce some error in issuing some gestures. So, for instance, from this study, we can see that swipe gestures are producing a little bit more errors, but not too much, 6%, as opposed to grab and drag gestures. So the error rate for those swipe gestures is a little bit higher, maybe not for for direction, but not for output. So error rate is also a way to estimate efficiency. Recently, I also discovered two other properties, which looks like a little bit like, as I said here in this example, where there is a discrepancy between the intended gesture and the recognized gesture. So what they say is that they measure two metrics. First, the reproducibility, which means that of the gesture with task intent, the rate of gestures achieved as intended is the ratio of that. So if the user has properly issued the right gesture, then this reproducibility rate estimates the ratio between the intended gestures and the total amount of produced gestures. And the second criteria is the relevance, is that when there is a gesture for each task, it is the rate of a gesture that is performed as intended for the task, which means that if this is the right gesture for this task, then it means it is related to the task. For instance, I can produce a gesture that is maybe correctly reproduced and well recognized, but is not relevant to the task. For instance, if I'm moving my hand up and down in order to increase or decrease the volume, then in case it is relevant, and of course it should be recognized. But maybe sometimes I can say I can do this gesture or that gesture, but it's not relevant. Other people are also using very physical measures. Like in this experiment, where they have used Kinect, they estimate also the error in terms of rotation. Indeed, producing a gesture in space is very difficult for us who are human in terms of perception of depth, because we have, if you can see on my camera, we have a binocular vision, which means that, of course, with our two eyes, we compensate the depth by calculating the distance by interpolating things, but we are very bad in perceiving the depth. So from the transversal plane or the sagittal plane, we are very good in producing gestures, but in that axis, we are very bad. So if I have to say, for instance, if I am drawing a circle like this, it's likely that I will reproduce it very accurately. If I'm doing it this way, it will be not so accurate, but still. But if I have to do it this way, it will not be very accurate, because our human eye are not good for that. And this is due to our vision. So this is why 3D gestures are very good, especially if we keep this plane and this plane and not that plane, for instance.
I have a question.
Sure.
Do people naturally produce gestures which are precisely likely to be recognized because of the limitations of our vision system?
Yes, but not frequently. Mm-hmm. Like, for instance, in order to move in virtual reality scenes, for instance, people like very much like left, right, top, bottom, but also upward and backward and forward. Mm-hmm. So if it is just this direction, it's okay. Because I can, if I'm doing this, like pushing for going forward or doing this for going backward, that's okay. But if I have to produce a gesture that is precise according to this plane, then the accuracy will be very much risky.
Mm-hmm.
So as long as the gesture is rather simple, it's okay.
My question is probably linked to some of the topics that we discussed 2 teleconferences ago about natural gestures in humans. I'm using one at the moment.
That's right.
Yeah, so maybe there is already a selection process which drives us some way to use natural gestures that we know work. And maybe it's also because of these constraints that we have in relation with vision. That was just what I was suggesting. We are not producing gestures in the void. We use them.
No, but if, for instance, depending on the distance, like if I'm considering the range of motion, like for instance, if I'm producing, let's say, a circle close to my face, or at a certain distance, or very far away, usually people tend to produce gestures either close to her, to her body, or at a certain distance, but not very far away. So if I'm, let's say, if I'm like this, it's unlikely that I will produce a gesture like this.
Mm-hmm.
At least when I'm interacting with a computer. Maybe if I'm in the front of an audience, I may, especially because I have very long arms, so I can, of course, expand.
No.
But it's unlikely that I will produce that because usually it is interpreted as inappropriate gestures.
Mm-hmm. Okay.
So the range of motion, when we observe it, is that I would say maybe 30% of gestures are issued close to the body. Yes, and I think that's 60% are medium range, and 10% are very far away. So it's very low. Usually it's 10% because of that, but also probably because it's more tiring. If I have to do this one, okay, for a few times it's okay, but if I have to repeat that after a while, I will need the gorilla arm.
Mm-hmm.
So in some other people are also using physical measures, like here the error in terms of rotation is that if I'm producing, let's say, a gesture with some rotation, again, we are not very good in reproducing accurately a gesture with rotation. So of course we can rotate like clockwise, counterclockwise, etc., or even that way, or that way. But we can't do that. We can reproduce that very accurately. So the third dimension of usability, but this is traditional, the third dimension of usability, as we can see in the ISO standard, but also anywhere else, is that we have also to measure the subjective satisfaction of the user. So for this, we have seen so far that we have several examples, like to what extent is it a natural gesture or intuitive one? To what extent my gesture can be accepted socially? Again, if I'm talking and I'm explaining like this, probably this is okay. But if I'm starting to do like this, or like this is probably inappropriate or even confusing. As a joke, but I'm no longer doing it. Some years ago, while I was talking about things that are appropriate to the context, for instance, in a classroom, I jumped on the desk, and of course, students were, oh, what? What are you doing? So this is an example of an appropriate gesture. Because probably nobody would expect me to jump on the desk, especially in a classroom. So, but this is, of course, based on convention, and conventions are, of course, arbitrary. But again, here, if I want to evaluate the subjective satisfaction, I need to take that into account. So a gesture that could be acceptable, maybe while I'm interacting with my own system, could be accepted, but could be rejected if I'm doing the same gesture in front of a public display. So all of these things come into account in order to measure, at least to estimate the subjective satisfaction. So if I want to evaluate the complete thing, the complete aspect of interacting with gesture, so I have those 3 dimensions here, which cover usability as traditionally, so this is not secret, it has been done for years. And for all of these things, I have 2 parts of the coin, 1 part for the system and 1 part for the user. Like for effectiveness, the part of the coin for the system is about the recognition rate and time, but for the end user, it's about the task completion time. But this is not enough. So what we are trying to explore today is to go beyond usability. So if usability is covered by those 3 dimensions, effectiveness, efficiency, and satisfaction, we know that today user experience goes beyond mere usability. So for this, we have also to measure what is the gestural experience. And the user experience is influenced by several other parameters or properties or quality properties. Like, for instance, one of them that is very difficult to measure is the playability or even the pleasurability. So those characteristics here are related to the so-called hedonic dimension. It is, maybe I'm not happy with a gesture, maybe it is hard to produce, but I like it because it's fun. And if the fun character is more important than all of the others here that I have just briefly sketched, then if fun is the most important, even if it takes time, even if it is complex, or even if it is hard to reproduce, if the fun character is the most important for the end user, we have to keep it. So this is the part of the user experience. So if we want to estimate the complete, or at least the extensive experience with gesture, we need, of course, to take into account the recognition performance, but also the preference. So what we are trying to do now is to imagine, but this is, of course, an ongoing research. We don't have yet enough result for that. We try to estimate the overall quality of a gesture user experience and not just usability. Of course, usability is here, but the user experience now is there. So if we combine all of these things, then we should come up with what I'm calling a GUESS. It's a gesture user experience special scale. So in order to estimate that, I'm taking inspiration from the attractive scale. So attractive scale is a user experience scale that has been introduced by Mark Assenzahl, and which try to categorize any system, so any interactive system, whether it is based on gestures, yes or no, on 2 axes. The performance on one hand, which is of course related to the system, not the user, and the preference, which is related to the user and not the system. So if we say that for each axis we can decompose it into 3 regions, like the performance is low, medium or high, and also similarly for the end user we can say that the preference is low, medium or high. Of course the desired or the most expected one comes into the top right rectangle. So for instance, if I say that the performance of the system is low, so the system does not recognize my gestures and I don't like the gestures, so in this case it will be superfluous. What we can see today is that several systems are very good for the performance. We have seen, especially with machine learning techniques and deep learning techniques, once the gesture set is completely specified, then we can run those excellent machine learning techniques and the recognition rate is almost perfect, like 95%. But on the other hand, so we are in this column because the performance of the system is very high, but the user preference is usually low to medium. so they perceive it like it's a system-oriented gesture, or it is just for the sake of being recognized by the system. On the other hand, when we introduce the gesture elicitation study, usually the preference is maximized. So the gesture that come up as an output from the gesture elicitation study, they usually reach a very high consensus, or at least some consensus, therefore some preference, but their recognition is not always very good. So if I'm here or if I'm here, it is always maximizing either the system performance or the user preference, but not both. So ideally, I should not be there, but I should be more or less in this region. I have to try to reach the top right part of that. So that was the attractive system from Mark Assensal. Maybe we can have a look. If you type attractive, and they have now an online system. So if you want to try, you can see it's not just in German, but it's also now in several other languages. But it's like that. So this is based on user experience. So attractive is an interesting scale for that. But what we want to do is to come up with something similar, but for gesture. So in this case, we should again be in the top right corner by maximizing the gesture recognition, but also maximizing the user preference. And this is something that has been already done, like for instance, in this reference. They did not come up with a specific scale, but they applied the attractive to compare two systems. And so what they did here, they compared two systems for interacting in the car while we are driving. So imagine that I'm a driver, I am driving my car, and I can interact with the infotainment system or with the radio or with the SMS messaging system in my car. And they compared two different user interfaces. One with only touch. So I have a screen and I have to touch all the buttons and the commands in order to control my stuff. Or I can do that with gestures in mid-air. So there, what they did is indeed, well, of course, it was an extensive study, but I really recommend you to have a look at this one. It's a nice comparison. What they come up with is that the touch-based system, although it is based on gesture but touch, they reached only the middle of the attractive matrix. And surprisingly, but this is a good sign, the mid-air gesture system was already in the top right corner, although not so much on the hedonic quality. So that was an example of application. So what we want to do is to do the same, but in a more general way. And for that, in order to come up with this result and to compare the touch-based version for in-car interaction with respect to the mid-air one, they used several metrics to evaluate the two systems. First, they used the acceptance in terms of whether people perceive it as a useful system, yes or no, in different contexts. While I'm driving in the city, maybe with a simple driving, like for instance, I'm queuing, so my workload is not very high because people are queuing in the lane, so I have maybe more attention for something else. Or I'm in the city but with a complex one, like for instance the traffic is high or it's peak hour, so my attention should be lower. Or on the motorway with a basic one or a complex one. So as you can see here on the left you have the gesture-based system, and on the right you have the touch-based system. So the perceived usefulness, not real one, the perceived usefulness, as you can see, in most of the 4 conditions is superior for gesture-based as opposed to touch-based, which is very interesting to know. So here, the nice thing is that not only they evaluate the gesture-based system, but also they compare it with the same functions, the same context, and the same people, but not with the same user interface. And they did that with several metrics, like also the subjective satisfaction. Again, you can see a difference between the gesture version and the touch-based one. They also performed the NASA TLX, but now, as you can see here, the NASA TLX, not in its complete version as I introduced a few slides before, but the traditional one, the scores are lower, not because it is worse than the touch-based system, but because people thought that the workload was not so high as in touch. Why? Because of visual attention. Is that, of course, the main difference, as you can imagine, from the gesture-based to the touch-based one, is that the gestures do not, the 3D gestures performed in mid-air do not require visual attention, as opposed to a touch-based, which requires my attention to the screen. So, for instance, if I want to increase the volume of, let's say, of my radio, with a touch-based, I need to select the command on my touch screen. If I'm doing the same with gesture, maybe I can perform that in the air and I don't need to pay attention to any screen. And finally, what they did also is to compare the two user interfaces with a few statements. Although here, those statements, they introduced these statements themselves. It's not like an established scale which has been empirically validated. So they have introduced their own statements, which I think is fine. But of course, it is not an empirically validated scale. And in order to confirm that the gesture-based interface required less attention or less cognitive workload than the touch-based, they then performed an evaluation of how many glances do the driver produce while driving. And here you can see that there is a really big difference. Of course, with the touch-based, so on average for each task, it means 4 glances at the screen. Well, if I'm considering this one. And so in order to perform a command on a touch-based user interface in a complex or in a tense atmosphere, it means at least 4 points of glance on the screen, as opposed to almost nothing for gesture. So this is the big difference. Now, all of these things, what I've sketched here are different metrics, like we have seen the NASA TLX, which is of course a general purpose way to evaluate the workload of systems. Depending on which type of gesture base they want to use, they use different metrics. So these are the measures or the properties of the to measure. But now the question remains is that what type of methods can we use in order to evaluate those things? So again, if I come back to an old piece of work, but which I like very much, is the classification of evaluation methods from Whitefield, which says that evaluation method, but this is very general for any type of system, can be represented along 2 dimensions, the user and the application. So for both of them, we can imagine whether the user is a real one. I mean, for instance, in the previous case, it's a real driver, or it is a representative. So which means it is not a real user, maybe it's somebody else, or it is a model of the user, or a simplification of the user. So if the end users are the real persons who will use the system, then we are here, otherwise we are there. Similarly for the application, if I'm using a prototype, then I will be in the represented part. But if I'm using the real system, and not just a prototype or not just a mock-up or a sketch, then I will be in the real part. So according to those two dimensions, we can decompose the evaluation methods. So typically, when I have not a real user and not a real system, but a representative user and maybe with a subsystem, then usually, again, in general, not just for gestures, we are relying on analytical methods, where we have a user model and a model of the application, and then we compute theoretically things to evaluate. If the user is real, then we have the chance to get things from the user. Although the system or the application is not the real one, at least we can have real feedback from the real users and not just methods or models from the user. So analytical methods are good, but they're pretty much appropriate for prediction, estimation, and things like that. Now, if I have the real system, but the user are not the real one, but they are represented maybe like by experts or by domain experts or by usability experts, then we can go to reports produced by those experts. The best, of course, is the bottom right quadrant, where we have, of course, real users and with the real applications. And then in this case, we can really observe how people will use the system. So it was like that. In this case here, it was a real system with real drivers. So therefore we were in the bottom right position. So if we know that evaluation methods can be classified according to those two dimensions, user and application, whether it is a real one or a partial one or a representative one, then we can use different methods. And typically, what we observed for gesture-based systems is that we don't have a lot of analytical methods. We have some observation, but not a real method. So far, when we examined how people evaluate gesture-based user interface, many questionnaires are used, sometimes design tests, iterative evaluation, but very rarely other things like static analysis or dynamic analysis. So let me give you some example of that. Yes, so that was the classification from Whitefield, which was introduced in the 90s. More recently, Christian Rohrer, I'm sorry for the bad pronunciation, went a little bit further by also classifying evaluation methods according to two axes, whether it is qualitative, for instance, what do people think or what do people say, and quantitative, whether people are actually doing things. So for instance, if I want to evaluate the gesture completion time, I can measure it quantitatively. Maybe in order to produce this gesture, it will take 2 seconds and 2 more seconds to recognize it. So this is quantitative. On the other hand, an end user may perceive it as a qualitative factor, whether it is fast or slow or between. So what is interesting is that in this graph, many methods for evaluating a user interface are located depending on whether it is qualitative or quantitative, or whether it is an attitude of the end user, and they say what they think, but not what they do, as opposed to their behavior. Here they do, no, we know what they do. So the difference between the attitude and the behavior is that here in this part, we really evaluate the real behavior of the user interacting with the system, and not just the perception, which is here. So this is why some methods are really appropriate for measuring the attitudes, while some others are more appropriate for the behavior. So if I sum up, there is a big difference between what people actually do. For instance, if they perform some gesture, the system is recognizing their gesture. This is purely behavioral. But on the other hand, it is what people say they do and not exactly what they really do. So this is a difference. On the left, it is qualitative, so it is perceived why and how. When it is quantitative, it is really about rates, time, and stuff like that. So consequently, on this graph, what people say goes, well, this is my interpretation again. In this case, it's no longer the work of Christian Rohrer. What people say is pretty much related to preference. Is that if people say they prefer this gesture, we have to take that into account, even if the performance is not good. On the other hand, if we look at some gesture recognition and the system is efficient to recognize that, so the performance is probably very good, even if the preference is not high. So of course we need to be, so in order to take those two high-level criteria, performance and preference, into account, we need to have a bunch of methods. The problem is that, of course, we can have a gesture recognition system that is highly performant but not preferred, or that is very much preferred but not performant in recognition or in handling. That's the tricky question. Here, I refer to a more detailed version of that, but this is for reference. Now, in this landscape of general purpose evaluation methods, let me illustrate a few of them which have been already used so far. This I will skip. First of them is the guideline review. So guideline review has been very much popular for graphical user interface, where we have usability guidelines, design rules, or heuristics, and then we just check whether the guideline is verified, then it's okay, or violated. So here are a few guidelines coming from Microsoft application gestures, which says, for instance, you can use if you are using the triangle as a gesture, then the triangle should be in a single stroke without lifting the pen, and make sure that the top of the triangle points upward. So if we have this gesture, we have to be sure that the guidelines recommended by Microsoft will be properly addressed. Similarly, if I'm using a curly Q gesture, then again, the curly Q should be produced at some angle from lower left to upper right and start on the word that you want to cut. So again, these guidelines are, of course, very well stated and very well established, but it is difficult to properly evaluate these guidelines. So if we go back to my classification here, so guideline review is, no, in this case, guideline review is where the user is represented by an evaluator, usually an expert, and the application is not really the real one, or maybe it could be real, but then it is basically expert report. So guideline review, it's okay because expert can perform a guideline review of the guidelines related to gestures, but of course this is not with a real user. So if I go back now to those guidelines here, of course I can check them, but this will not necessarily, even if I have a perfect guideline review, I can come up with a gesture-based interface that is not usable enough. For instance, in this example, you may question, or at least myself, for instance, in my life, I've never learned dactylography. And since a few times now, I know that the curly Q gesture here is the typical gesture in stenography, or not in dactylography, in stenography, I guess, to cut something or to mark a word or a piece of words in a text, to cut something and then to replace by something else. So if I want to annotate a text, then usually people who are aware of this gesture from stenography, they are using that. But if you don't know that, for the end user, for instance, it won't make sense if there is no semantic meaning related to that. And as you can see here in this guideline, there is no explanation why the curly Q should be used in that context. So why the simple curly Q should be used for cut, and what the double curly Q should be used for copy, and not another one. So again, you may agree with these guidelines, or you may completely disagree. It depends. So beyond guideline review, we can also, of course, in the same vein, rely on heuristic evaluation. And there are several heuristics, like, for instance, here are some heuristics coming again from Nielsen or from Donald Norman. One of them says the system status should be always visible. Again, this is a general purpose heuristic, nothing specific to gesture, but still applicable. And here are some feedback that was collected in the below paper when they performed some heuristic evaluation of a gesture-based. So there was a violation because originally the system does not tell the user whether the Kinect device was connected and on. So the participant did not know whether the Kinect was switched on, whether it is working, and properly recognizing the gestures, yes or no. So this was considered as a major usability problem and important to fix. So improvement, we should add a Kinect status viewer. Again, another example. If you remember that I've shown you the armband from Talmic, as it's that one. Let me show you again. Talmic armband. It's a very nice device which computes muscle contractions and decontractions, like this one. You can. So here is an example of it. Once it is calibrated, the system senses my muscular contractions and decontractions in order to recognize some gestures. Fine. But while I'm using that, since it is a 3D gesture system, in principle, I should not look at any screen, which is the advantage of that. But in fact, there is a violation of this heuristic, is that we don't know, or the end user, even myself, I use it. Sometimes I'm confused because I don't know whether the system is working or active, yes or no. So now in the second version, they added an haptic feedback, is that when it works, you can feel it by, because there is a haptic feedback on the muscle, on the forearm. But if I have to look at the system or if I have to look at the screen, then I'm losing the advantage of a gesture-based system. A second heuristic that they have also tested is maximizing recognition, even if it has even if it is at the price of reducing the recall, which means that when a person is producing some gestures, the immediate recognition is even more important than recalling the gesture maybe 1 week after. So, of course, we can use those heuristics, but the key problem is that since these heuristics are general purpose, they are valid in principle for any user interface, but usually for graphical user interface, some of these heuristics do not make sense anymore, or are difficult to apply. Like visibility of the system is not visibility. If I'm going back to my my Talmic Mio, the feedback or the way I know that the system is working, is switched on, and is actually recognizing my gesture should be provided by haptic feedback, or as you can notice, sometimes there is a small blinking icon here. But again, you have to look at it. If I have to look at it, it's no longer high free interaction. So I'm losing the advantage of not looking at anything. So the heuristic is no longer appropriate as it is stated like that. So instead of visibility of the system status, I should say something like immediate feedback of system status or continuous information of my system status, and it should not be visible in this case. So even the statement of the heuristic is a little bit contradictory. If I want to go for high free interaction, then I don't want to include any visibility. So this is tricky. Now, if we are performing heuristic evaluation or guideline review, again, we can debate on that if you like, whether you agree or not with these guidelines or these heuristics. In the end, we can come up with reports like this. So this is something that we did with some system, is that we considered a series of guidelines. And for one system, we observed that 70% of them were correctly applied, while almost 1/3 of them were not respected. And this was a system with no weights. When we were applying some weights or some difference, then the proportion of unrespected guidelines was even higher. So into more details, we added a weight for each guideline. So from 0.1, which means this guideline is very much unimportant, to 1, it is very much important. So instead of just saying a guideline is respected for this system, yes or no, which is a little bit black or white, here we have a distribution of how many guidelines were respected, yes or no. Or for instance, Nielsen, but not Jacob Nielsen, it's another Nielsen, he proposed to have a scale like if it is a weight with 0 is not a real usability. If the weight is 1, then it is cosmetic, so it is not important. 2, if it is a minor one. 3, major. And 4, it is catastrophic. So it means, in this case, the end user is no longer able to carry out her task as expected. So of course, these are different scales. Another family of evaluation method is, of course, by questionnaire. By questionnaire is again very easy, it's very straightforward, and it's very cheap. And we have seen already many questionnaires for various aspects like social acceptability, for fun, for comfortability, playfulness. The problem is that with questionnaire we can have many questions, and they are not always very precisely stated. So here is a good one. For instance, do you think that your gesture is, 1, very easy to execute? So it's not just saying it is very easy or very difficult, but also to have an interpretation of the rating. For instance, if I say, and this is coming from Radu Vatavu's work, he used this scale for rating a gesture. So do you think it is very easy to execute? So it means that the participant is able to execute this gesture immediately, so without thinking, without making effort, and without paying too much attention. On the other hand of this continuum, very difficult means the participant needs really to concentrate even before issuing the gestures. So for instance, saying, so I want to make a copy. Okay, so copy, since I'm using Windows, so I have to use the double curly Q, so I have to do that from the bottom to the top, and then I have to do it. So in this case, it's very difficult to execute. But of course, this depends very much from the participant. Myself, for instance, in the past, when I didn't know that these gestures came from stenography, I was not very much fond of them. But as soon as I knew the reason, it was much easier for me to memorize them. So if I'm using this rating scale, yes, of course, you can also make rating and ranking at the same time. So for instance, here we have on the left, we have rating with a distribution along the median value, and on the ranking on the right, we can see which one is more or less preferred. So for instance, here the solution one is this one, then it is decreasing. But for this one, the other one here is not so much preferred, is not so much ranked as the other one. So rating and ranking can be combined, but it is of course difficult to interpret. So here is an example from Radu Vatavu's work, again, by comparing rating and ranking. What he did is that he measured several metrics for each gesture, but they are very, I would say, very physical metrics, like what is the length of the gesture? What is the turning angle of a gesture? These are very precise measures, and he was able to estimate the correlation between the rating and the ranking. So for some of them, for instance, if the length was well rated, the ranking was also good enough, and vice versa. So here is an example, and he derives some rule for that, is that a gesture A will be perceived as more difficult to execute than a second gesture B if the total production of time is greater. And this guideline is in 93% true, depending on the experiment data. So it means that if for a gesture A, the time is greater than for a B gesture, then it's likely, and with 93%, it's likely that people will rank it higher than the second one, not surprisingly. But there are some other cases. I will not detail all of them, but there are some more. A second rule is that the mapping from the production time to the difficulty class, we have seen here that there were 5 levels of ratings. So based on that, the distribution of gesture is very different. So very easy, moderate, difficult, and very difficult is that when it is very easy, the rating and the ranking of those gestures are much higher than the other ones, not surprisingly. And the accuracy of that is 83%. So again, the perceived difficulty of a gesture is related to its rating. And here there are some others, like how many points or how many strokes, although this was not significant. The length of the gesture, if I'm doing a gesture like this, which is very long, then its rating will be low. If I'm using, of course, 1 or 2 hands, or if I'm considering the time, of course, or how many strokes. So all of these things, well, not all, but most of them have a direct implication. Now, a little bit more closer to gestures, I would say, is the GUS, or Gesture Usability Scale. Very popular in human-computer interaction. There is one very popular scale called SUS, or SUS, I don't know in English, which stands for System Usability Scale, which has been introduced by James Brooks since the 80s. And this system usability scale consists of 9 statements, which are here from 1 to 9. Okay. And then in order to evaluate any user interface, then we have to ask participants, please give me your rating for these statements from 1, which is the lowest value, to 9 or to more, to 10 for each statement. So the higher the value, the more important it is. But be careful, because but this is done on purpose. Some statements are presented positively. I think I would like to use a system. So this is a positive statement. But there are also negative statements. I found the system unnecessarily complex. So instead of saying the system is very easy, it's unnecessarily complex. And of course, in this case, the value could be higher. So on the one hand is agree or disagree. So the very important thing with SUS, with the SUS questionnaire, is that the Cronbach's coefficient is, as far as I remember, is 0.91. So it means that the score provided by the SUS scale, so here we'll discuss this in a few minutes, is correlated with a factor of 91% with usability of the system. So it's probably the highest that I know. For instance, in comparison, the correlation rate of the IBM questionnaire on computer satisfaction is 0.89, which is already very good. But SUS, I think, is 0.91 or 0.92, as far as I remember. So again, we could say at first glance, since the system usability scale is a good scale to evaluate any system, then let's use it for gestures. Yes, that's fine, but we have to keep in mind that this scale has been mainly used to evaluate graphical user interface, and there was nothing about gestures. In addition, this scale has been empirically validated with hundreds of systems. So when we have a score that is calculated by the SUS, we know that this score is with 90% of confidence related to the usability or the perceived usability of the system. So since there is nothing specific to gesture, Daniel Wickroth and colleagues introduced some more statements on top of SUS, so they call it GUS or GUS for gesture usability scale. So they added a few more statements that are specifically tailored to evaluate a user interface involving gestures. Like, for instance, the system recognizes the gestures reliably. If you remember, this is related to performance. Or the system followed the movements as expected. So here, maybe this is also to performance. The reaction time of the system is satisfactory. So this is pretty much related to efficiency. And the system reacted to my movement too slowly. So again, this is more efficiency. So although those researchers did not perform any empirical validation of their questionnaire, and they used it only once, on their example, they performed the SUS and they obtained a score of 72.8. And for the GUS part, 67, which makes a difference of 7.1. So if we look at the interpretation of that, usually the system usability score should be interpreted like this one. Well, of course, there are different interpretations and different scales, but this is one of the most frequently used, is that when the score is above 75, then it is good or even better. Like for instance, when it is 85, it is considered as an excellent. If it is between 55 and 75, it's marginal but still okay. And when it is below 55, it is not considered as usable. So Brooke, what he did is that he compute or he gathered the SUS score for many systems, I think hundreds of systems. Then he classified them according to types, whether it is for geography, for electronic commerce, for information system or whatever. And then the score means to what extent a particular graphical user interface is superior or inferior to all the other ones computed so far. So this is how he determined this scale. And this is an empirical validation, which is not the case with the GUS. But I think it's a good attempt. Again, why those 5 more items or 6? I wonder, yes, there are 6. Why more items? And you can, of course, question them as well. For instance, if you say that the system reacts to my movement too slowly, so this is something that is related to speed. So reliably means something that is related to recognition rate. Here as intended, this is the subjective satisfaction, and this is the expectation. So these are related to various aspects, but they are not very much made explicit. So I think this is a good idea to come up with such a scale, but to my knowledge, there is no empirically validated scale like that today. The only attempt is that one, and we were trying, but is not yet effective. So of course we can evaluate also by metrics, and we have seen several examples, like what is the production time, how much time do I need to produce a gesture. So here they compared gestures produced with a Kinect with respect to a leap motion. So in the first case, the leap motion gesture, when it is produced and recognized by leap motion, required less time than with a Kinect. Okay, and the second one is not so, the index of performance based on the Fitts law is a little bit different for different types of users. So for the children, the performance was higher with the leap motion, but young adults not more, and surprisingly for older adults the performance was better. So again, depending on the metric, we can have different results, and this is very difficult because we can come up with many metrics. So the key question, and I would like to finish on that, is that again, if we go back to this graph, between what people actually do when they are producing gestures and what they say they do, but they do really or not, or they say they like it, but in principle they don't necessarily perform well with what they preferred, and they do not prefer with performance. So I think we have to cover several aspects and not just the preference. And when we conducted some gesture elicitation study, this is pretty much based on preference. But when we move the most preferred gestures to the performance, especially in recognition through recognizer, the performance is very much different. Some gestures are very well recognized and some others are very badly recognized or difficult to recognize. So combining all of these things is the challenge of today. So what we are trying to do now is to explore this big graph that we have drawn. Of course, there are many possibilities, and we don't know yet today to what extent these factors contribute. We know some of them, like for instance, the recognition rate today, we can come up with almost a very good rate, which is above 90% of recognition rate. So it really influences effectiveness. Recognition time can be very short as well, but this is not so much important as the rate. For the end user, the recognition rate is more important than recognition time. So we know that the correlation factor are about that. But what about, for instance, the learnability or the memorability? We know that these factors impact efficiency, but to what extent? As you can see here in my big graph, I have a lot of question marks everywhere, because I don't know to what extent these criteria or these factors may influence either the usability per se, so those 3 dimensions, or the user experience, or the total quality of the gestural user experience. So there are many question marks, and I think that here there is room for many experiments. So I'm not a specialist for experiments. I'm a computer scientist, not very much a sociologist or a psychologist. So in principle, we should explore all of this correlation, but this is a lifetime work. So in order to, maybe not to conclude, but at least to finish with some, let's say, some thought, we can say that gestures offer many opportunities, but one quote that I like very much is that, again, from Nielsen, not from Jacob Nielsen, who is the usability guru, but from another Nielsen, who introduced a method for classifying gesture. He said that when developing a gesture interface, the objective or the goal should not be to make the gesture interface, but to try everything possible to make the gesture interface efficient, of course. So the goal is not just to introduce the gestures per se, it's not for the sake of gesture interaction, because probably sometimes a gesture interface is not the best. But if we have to go for a gesture-based interface because the conditions are favorable or suitable for that, then we have to do everything possible to make it efficient, effective, and sufficiently satisfying for the end user. So this is my last word. Thank you very much, and I would be very happy now to hear from your questions or comments or criticism or whatever you like, or your gestures. Your gestures. Now the gesture is yours. And you could say, again, also depending on the country or depending on the culture, maybe you had, how do you pronounce your first name? Suayo? How do you say it is good? Is it like that? Or bad is like that? Or maybe, yes, this is very good, or this is not so good? What is your favorite gesture?
This one.
Thumb up?
Yeah.
Mm-hmm. Which is coming from the ancient time, from the Romanian, you know that? Do you know the meaning of that?
Sorry, can you repeat again?
Yes, the meaning of the thumb up or thumb down actually comes from the Roman, the
Romans.
ancient time of not the Romanian, the Roman. When there were some gladiators in the arena, there were a combat, let's say 2 gladiators against each other, and when one was probably winning and the other one was on the ground, then probably the winning gladiator asked Caesar, or to the people, would you like the other one be killed, or would this gladiator would live? And this is the sign in Latin is habet. No, habet is like this. Habet, it means he will die. But if it is like this, he will not. And since that time, we keep it, this is positive and this is negative. So this is a very old cultural meaning, right? So you may agree with it or you may disagree with it. And you may say this is okay because it's a plus. Or somebody else could say, no, this is not a plus, it's just cut it because it's enough, right?
I think it's commenting the negative one means no or very negative meaning.
Right. It's like a cross, right? So a
Yeah.
cross means something probably negative.
Or arrow. Yeah.
But surprisingly, the thumb up and thumb down comes from a very, very long time. Probably popularized by Facebook. I don't know. Questions, comments, or criticism?
Maybe a question on my side, and it echoes probably some of the things we said before. At the end, you spoke of all these dimensions, which you want to correlate to determine in advance if a system can be predicted to be good or not. Do you think such a theory is possible?
No.
Good.
No. What I think is that it is important. I think it is important to identify these factors, but in the end, to just pick a few of them. But the most important is to recognize which one are important for the particular system that I want to develop. And so if I come back again on this big picture with all these factors, that one. So here on the left, I identified many factors, which are themselves sometimes decomposed into sub-factors, like workload. If I'm estimating the workload with NASA TLX, then I have to decompose it into mental, physical, temporal, etc. So this is even more complex. So if I want, in the end, to have a full gesture user experience scale like that, I think this is impossible to cover all of them. But at least to be aware of them and then to choose, okay, maybe the recognition rate, I know this is very high correlated. So in this case, let's say I want to develop a gesture-based system for this particular case, then of course, recognition rate will be considered and recognition time as well. Maybe learnability, because I want people to quickly learn gestures. Social acceptability, if it is in front of a system that is inside an office, I don't care too much. And maybe playability, and that's it. Or maybe also physical workload. So I have to choose. Now the way to choose that's a key question. I don't have any answer, unfortunately.
Yes. So basically you are saying that this is a weighted graph, which allows you to compute a value in the end, on the right. And the thing is that the weight change depending on the context, the application, and so on. So you know little about them.
Yes, unfortunately. But if I knew, but for some of them, we know that, for instance, effectiveness is highly correlated to these factors. But for most of the other ones, we don't know, or it is. There are some experiments there, but they are not very much generalized. Like, for instance, social acceptability. I only know 2 papers about measuring social acceptability, but in a very specific context. So I'm not sure that the correlation would be that figure.
Yeah, and you said that there is room for many experiments, which would mean replace the interrogation points by actual values. But my feeling is that the values are not really static. They will depend on the context and between themselves and so on. So
that's right.
So it can be a useful guide, but certainly not a theory which is really predictive.
No. I see it more as a methodological guide to proceed and maybe to identify what is important. Of course, if I know that, again, with the example of the social acceptability, I know only 2 experiments on that. So if my context of use is similar to those which has been investigated into these papers, then maybe I can probably say that indeed there is a correlation of 0.3. But if they are not related, or if they are not comparable, if not suitable, I cannot deduce anything. the only thing I can do is that, okay, I will consider social acceptability and I will evaluate my system with a scale or with a questionnaire or with metrics. But that's all what I can say.
Mm-hmm.
Unfortunately. This is the only limit that I can do today.
And how do you see the same thing? I mean, we are talking now about gesture, but often today we also have multimodal user interfaces. So will it completely change the thing, I assume, because we cannot see the gestures on their own anymore? So if you would now take your gestures and combine them with sound or other things as part of your user interface, do you see any possibility to add that maybe to the graph you have shown, or how would that change?
Yes, but if it is multimodal, then we have even more.
Yeah, but that's what I mean. I mean, then he mentioned the context, but so it's getting much more complex then. I mean, we cannot see it just in the gesture space anymore, but of course the combination then of gesture with something else might change a lot of these weights, I could imagine, right, in there.
Mm-hmm. If we go to multimodal, then we have at least to cover each modality per se, individually, and their combination. For instance, in some electric cars, when you have the autopilot, you have three modalities. You have the gesture, you have the sound, and you have the haptic feedback for every command. So I've seen a graph, I don't remember, but I can find it. There was a table where they say, if you want to issue a command, like you want to drive or you want to go reverse, each time you enter a command, you have the possibility to do it with the three modalities, but also you have the feedback in the three modalities. So if you go, for instance, if you say, let's say if you go with the command reverse, then you can feel it like that, but it will produce a sound to say reverse, and you will have also an haptic feedback on the seat, so that you will feel that the car will drive reverse even before. I've seen a table like that, and I found that was very, very much interesting, is that not only the input is able for each modality, but also the feedback for each modality. And that they can be combined. So if I want to drive forward, so if I'm issuing the command, let's say forward, then the feedback could be done according to the three modalities at the same time. So it's not just one modality at a time.
I was also thinking, I mean, more in a case of, I mean, now it's just the alternative, right? But I was thinking more in terms of also Boltz put that there, where really combine gestures, you know,
That's
so
right.
that's a more complex command that maybe has a gesture part and then also some other modality involved there. I think then it's getting really difficult, right? Because I mean, we can then, it's a completely different weights we might have in this graph somehow. So I mean, it was just coming up now, and I thought this is very nice.
That's right.
Gestures only, but in this multimodal context, yeah, it will get very difficult, I think. Yeah.
Yes, especially there are, again, I'm not a psychologist, but there are many specialists who are studying people while gesturing with speech. And there are thousands of papers on that. I've tried to grab some of them, but this is beyond my understanding. Is that they look at how people when they are talking, when they are gesturing, when they are combining, and this is not alternative. So it's not saying, okay, mute, or no more any signs, any gesture, and then I'm talking. It's speech and gesture because they are intertwined in our natural behavior.
And very cultural.
That's right.
If you go to Italy or other places.
Yes. Yeah. For instance, if I'm doing this, in Belgium at least it means shut up, probably.
Yes.
But in Italy it means somebody who is very verbose. It's maybe I don't know how do you say in China, for instance, somebody who is talking too much. If there is any sign for that, I don't know. Do you have any? Like that?
Yeah, shut up.
Okay, so you see.
Or like use like a zip to
zip.
Yeah.
Interesting.
It's funny because we all know them, even if they are not the preferred ones, but they are quite familiar.
Maybe most of them, not all of them.
The two you showed.
Yes, the two.
We would have understood what you mean.
Yes, but if you're talking to an Indian person, you say, "Do you agree?" It's difficult for me to understand whether he said yes or no.
I think in Japan they do like that, right? I mean, in the lecture it's sometimes really a bit confusing, or just if they follow you, they do like that, and you think like,
and they never say no
all the time.
Yes, they never say no, especially when yes, it happened to me. I remember I was in Yokohama a long time ago, and I asked several people, "Can you tell me the way to that place?" And he says, "Yeah," and then they say yes, and in the end, it was totally wrong. But they didn't tell me that they didn't know the way. So again, speech and gesture are really intertwined, and so this is a real opportunity for multimodal interaction. But how to evaluate that? That's I don't know.
I have a comment.
Sure.
So I think that many factors have a close relationship with between human interaction, particularly if we want, for example, to assess the social acceptance of gesture. So the user try to inspire himself, so he takes the human interaction as a reference to assess the social acceptance of gesture, I think. Do you agree?
Say that again. So you mean that the gesture which are socially acceptable or accepted?
Yeah, are have a close relationship with between human interaction.
You mean human to human interaction?
Yeah.
Yes.
What do you think?
Yes, but not only, of course, probably we are relying on the gesture that we already know, but we can learn some other gestures that were not necessarily inspired from human to human. For instance, if I'm doing this gesture, this is a typical, well, for some people, this is a gesture for a screen. But I didn't know unless, again, it's like the curly Q from Microsoft, or the double curly Q. I didn't know for years until somebody who learned stenography told me that this is the typical gesture for stenography. And since I didn't study stenography, unfortunately, for me, I didn't know. So I was unable to not only to understand the meaning, but also to remind or to recall the gesture. But this does not mean that I will use it in the future. So even if it is maybe for copy or for paste or cut, I don't know which gesture would you like to do, if it is a 2D static gesture, or if it is a 3D gesture, or a big gesture. For instance, I may want to say cut, why not? Or separate. There are many variations, many articulations.
I still have a question on my side, if okay.
Yes.
Yeah, you probably remember the first teleconference we had where we discussed the notion of meta interface. I think it's the way you call it. So it was really based on the idea: can we really design such things in advance in a way which is predictable of the validity and the quality of the end result, and the conclusion seems to be no, or more or less, but in reality no. So the design space is so complex with so many interactions and so on that it's really a design problem in general, and we can have theories about design, which is really finding a spot in a design space, and this there is no predictive theory for doing that, at least in this domain. So the idea is probably to use some more iterative methods and naturalistic methods where we design something as a sketch, and then we put it in practice and we see how it evolves, which allows things to evolve, and that's exactly what happened with human-to-human interactions. And also to assess how well it is evolving, and there maybe the methods that you are using to measure the quality or satisfaction of the interaction can still be used, but I think there is really room for this kind of approach where you start with an MVP and minimal viable product, where the set of gesture is the MVP, and then you see how it evolves naturally, because the tool that you use to evaluate things and to find an optimum is really the system itself. It's the people to system interaction, and it's this notion of co-evolution. So I think that in general, in such complex design space, it's impossible to design things in advance, and you need to have this kind of iterative and evolving methods. What do you think about that?
Yeah, again, if I'm coming back to the last one that I said, the gesture interface is not necessarily the best interface for an application, but it's not just a static one. It should evolve. So this is why the concept of meta user interface comes into play, which is a user interface on top of the gesture interface of a system, in order to enable the end user or the designer or even the developer or any third party to come up in the process and maybe adjust things. So it could be the end user to say, okay, I want to replace this gesture by that one. And so for instance, if I say, in order to mute my media player, I want to do this gesture. So maybe Troy would like to replace the per default gesture in the system, which is, let's say, this one, or I don't know which one, by her gesture. While maybe Ketoma would like to have another one. And the system should be able to record that, and also to record how the personalized gestures will be used, so as to make the difference. Because if at time t we say this is the gesture, and then the end user or the developer or anybody else has changed or modified or improved or whatever, then we have to measure the difference. So this is why the system should not be only able to change or to modify the gestures, and then to ask the system, okay, please retrain, please re-improve and optimize all the process, but also to measure all of these aspects, and of course we cannot measure all of them. We said the length, the angle, the production time. These metrics are not so complicated to measure. But if at some time we say, okay, maybe this gesture, which was the per default gesture, is very good, well accepted, short, but the end user comes with another one that is maybe longer or harder, but more funny or more understandable for any reason, then we have to identify which metric has been improved. That's difficult.
Yes, but do we need to do that and go into so much details? Maybe we just need to look at task performance. The user wants to do something. Does he succeed or not?
Yes. And for the sake of the interface itself, I don't need all of this stuff. But if I want, me as a researcher, I want to have a principle-based approach, I would like to know why.
Yeah, for the start, yes, indeed, okay. but after that, I think you have to design systems that can evolve easily and converge together to something which is really optimum and which could be idiosyncratic. I think it's the word even in English, and it's really specific to the specific user machine. Maybe, I don't know, something which evolves. And then indeed you can learn of this evolution to feed into your principle-based approach. Maybe, yes.
Yes.
Okay.
This is what I hope, but it's not always the case. Again, an example from maybe I think I've shown you. Let me see if I can find it again. It was for mass-computer interaction. Or maybe no. Yes, this is the guy, but I'm looking for. No, just a minute. I'm looking for a video. For a gesture in a very large auditorium. Okay, this is that one. So let me show you again the accompanying video of that, which is about so-called mass computer interaction when you have hundreds of users in a room. So this is this one. I think I've shown you, but again, let me show you it again. I don't know if I have sound. Just try to share it again with sound. Okay. Now I guess yes, you have sound. So here you see in these games, which are with hundreds of people in an auditorium. So in these examples, the guy who implemented Lionel Lawson, who was a former PhD student, he said, "Well, I'm asking you, how do you design your gestures?" And you have seen people doing sometimes they're doing sometimes or sometimes different types of gesture, and it was a pure empirical approach. So no measure, no time, just saying, okay, we can recognize these gestures, let's do it. And after several iterations, he said, now I know my perfect gestures after several years, he confessed. And I have some idea why they work, because they are, of course, they are fast, they are easy, or they are enjoyable. But I have no principal idea why those gestures work with so many people. I just know now. And as you have seen in the video, and there are some other examples, where, for instance, in this game, let me see if you can. Okay. So one of the goals of these games, for instance, here, it's a movie theater, which is divided into two regions. The green regions on the right and the red one. So those people who are separated in visually, so they see this is on the screen, they form two teams. And then they have to throw away things from one group to another, like bombs, fruits, or explosion, or gifts, or whatever, or checks. And for that, they have to move or to throw away things. And then Lionel Lawson, who implemented that, told me that in the beginning, I didn't know the gestures. I tried this one, then it worked, so I kept it, and the other one didn't work, so I changed them. So, but he did that, all of this adjustment, he did that manually. Until now, the gestures looks perfect, or at least you no longer need to change them. So this is a perfect example of a non-principle based approach.
Mm-hmm.
I think maybe to follow up on that, I was just thinking now, but there is an interesting difference, I think, and a challenge in the gesture-based interfaces, because if you think about the graphical user interface and this evolutionary aspect, then you can see that even with all the big players, you can do some A/B testing all the time and slightly adapt your graphical user interface. But I think with gestures, it's the discoverability that makes it not possible, right? I can just not roll out new gestures and then see which one works better, because the users will not know what are these new gestures. I think this is an interesting new challenge compared to a graphical user interface, where I think you can do much more on this evolutionary aspect somehow, where you can just change it a little bit, but users will still discover the functionality, and it's not a completely new set of gestures that you bring in. So it was just something that came into my mind when Dennis mentioned this evolutionary aspect. Yeah.
And again, if they can discover it, that's one thing. But if they can recall or remind the gesture after a while, we don't know whether there is any correlation between. But usually it's the case. If they discover a gesture rapidly, it's likely that they will keep it in mind.
But I mean, for me, it was more like, otherwise that could be a nice way to have it evolve over time, right? But I think for gesture-based interfaces, it's much harder to do something like that. Right? I mean, it's then more again that you have to give the complete freedom to the user, that they can select maybe their gestures, and then you somehow do some monitoring of that maybe, and then you start to see which ones are used more often and so on. But you know that you can just do that in a very how should I say, a highly iterative process. I don't see it with the gestures, or I think it's much harder to do something like that.
Yes, and in addition, it's not just replacing a gesture by another one. It's also adjusting speed, size, articulation, variation. Because if I'm saying this is for increasing the volume up and down, okay, I can do it very fastly, and then the system will probably be in difficult situation to follow me. But if I'm doing this way now, so it's not just replacing a gesture by another one, it's also all of these parameters that needs to be adjusted.
And know the context again, because you might do the same gesture even in different sizes in different contexts. So I think it's quite a complex design space, actually.
I think that the principle-based approach helps understanding and keeping in mind these criteria. But again, on the one hand, I'm trying to have this big graph with all of these factors in mind. But on the other hand, for instance, Lionel Lawson says, I forgot about this. I'm just designing them. Of course, it does not have a lot of gestures. I think something like 10 gestures. And now he came up to a base of those gestures, and he no longer changed them. Even if the game that you have seen is different, more or less people are issuing the same gesture for the same meaning, even if the game is different. It's like a convergence, but we don't know how to express that. But this is what we observed. At some point, we thought with Lionel Lawson to examine the gesture interaction pattern that people are using. I don't know if in this video, maybe we can see it, I don't remember. Yes, no, we don't see it in this video, but in other one, for instance, there were two teams competing and they have to row. Like they had two separate kayak evolving, and they had to make this gesture to make the kayak progressing faster. And of course, they have to do it faster and faster, and the more people who are producing the gesture, and the faster the kayak progress. And then, of course, the team which gave the most gesture won the race. And of course, all people were sitting. And there was a video, I remember that was really striking. There was a father with his children. He came, but he was lazy, not very much. Okay, he said, I want to please my children, so let's go to this game. But he was not very much engaged. So he was sitting and lazy. And then he tried, okay, a little bit here, a little bit there. And then at the end of the game, after half an hour, not only he was no longer sitting, but he was doing something like this. He's he left his seat, although we said don't leave your seat, but he left his seat and he was playing like that in the alley in order to increase the size of his gesture, thinking that the size of his gesture will influence the system. That was a funny case. But we can't measure that. The only thing is that we can observe that he was lazy and not very much engaged, and in the end he was
Do you know of any studies on the evolution of gesture over time? So you train a user to produce some gestures, and if you had a system which is able to adapt and still recognize gestures which evolve based on the curves and the timing and so on?
No, I thought about that, but technologically we have the capability to do it, but I have never seen any, at least I am not aware of any study doing so.
Because it's a form of communication, and if you think of natural languages, if you think of English, for example, it's an evolution of Old German and so on. So all the languages, and you have these language trees with evolutions, and there are economy principles which govern the simplifications and so on. So there are really laws of transformations which are really about economy and efficiency and so on. So you probably naturally will have the same thing with gestures. And if you think of writing, which is also gestures, but for communication, take yourself, probably when I was 6 years old, I learned how to write. And now my writing has evolved a lot. And I'm far more lazy in my way to do it, and maybe probably far more optimal and economical in my way to do it. So I think it's quite natural for these gestures to evolve. And there are probably laws. And again, if we are looking for this optimal point where the system and the human interacts really efficiently, maybe we should allow them to evolve naturally towards this equilibrium. And that's where it would be really useful to know if there are such evolution laws for gestures.
No, for sure, there is some evolution until a certain stable state is reached. And in the game that you have seen with mass computer gestures, it was the case. It was working in the first version, but it was not optimal. And now Lionel told me that you no longer need to change them because the gestures are easy to discover, they're easy to produce, they're straightforward to be produced, and people remember them from one game to another. But we don't have any proof of that.
Okay.
We should examine the log files from that over time and compare all them, but this is a huge amount of work. But there are probably, I would not say low, but at least there are some process, some evolution process.
Yeah, but maybe there are laws, and
Maybe.
and then you would be in position to predict. Okay, I'm starting with this theoretical principle designed set of gestures, but I can already predict how they are likely to evolve, and probably in terms of simplification and that kind of stuff. Maybe if they get simplified, maybe it will be more difficult to distinguish between them, and there will be confusions and so on. I don't know. But it could be also useful to test the robustness of a given set of gestures against these laws. And if you are close to the equilibrium already, you will converge rapidly. If you are very far, you will go through a lot of transformations, maybe, and which means that your starting point is not good.
Yes, that makes sense.
It's very likely, if you look at linguistics, the evolution of languages, there are really laws which have been discovered in the 19th century. Yes, yes. And if you compare English, German, Dutch, Flemish, they are all from Old Germanic, but they have evolved in very specific ways. And there are laws which govern these evolutions. And it's due to cognitive aspects, to practical aspects. You need to be able to speak with enough volume, to physiological constraints and so on. All this kind of stuff will make. There are reasons behind the laws. They can also be explained. So I think I think we already have natural gestures. And so they are already the product of some kind of evolution, probably because of the same constraints. And if we are designing artificial gesture systems, they will probably tend to try to follow the same evolution laws naturally, because we are humans, after all, like Daft Punk would say.
That's right. Well, that's probably a good conclusion. It's almost 7.
Yeah.
So again, but thank you very much for joining, for contributing, for participating, and especially for staying until the end. Thank you very much for your participation and attendance. I will stop now the recording.